Okay, so welcome to the Stat 5820, the Introduction to Data Science. So my name is Kazuhiko Shenki. I'm a PhD statistician in the department. Yeah, so this course is basically a kind of the second course of statistics and data science. So the prerequisite is the Stat 5030 or the 5800. So I don't know how many of you have taken those courses. Have you taken 5030? Maybe I launch a pool. Okay. Still, I'm not really sure, but okay, so maybe I take a survey first. Yeah, I have seen many of you in the last year or last semester. Okay. Okay, so so if you haven't taken the 5030, have you studied statistical language R or not? Anyone who answered no, or you haven't answered? Have you studied any like language like Python or R or? You can turn on the mic.
Yeah, I mean,
yes.
Okay. Yes. Yeah. Yeah. So if any of you haven't studied R, maybe I introduced R a little bit after the introduction. Maybe it's sufficient. Okay. Great. So we start the course. Okay, so at first I would like to discuss the syllabus. So I will log in to the session from my iPad. Yep. Okay. Okay, so I think that you are now seeing the syllabus. So this is an online course throughout the semester. So unlike other courses, that we continue to be online synchronous throughout the semester because some of you have been taking this class because of the requirement for the minor in statistics, and the department commits to run all necessary courses for minor in statistics online. So that's the one reason that I run this course online. And obviously, the statistics courses are a good course to run online. Even if we use Blackboard, we cannot make scatter plot every time on the Blackboard. Yep. And my email address is this one, the shinki@thewayne.edu, or the seikibunpu@gmail.com. The seikibunpu means the normal distribution in Japanese. And we use Canvas as the course website, so quizzes will be uploaded to Canvas. And lecture, the Tuesday, Thursday, 5:30 to the 6:45 in Zoom. And office hours, Monday, Wednesday, Friday, the 11:45 to 12:30. Or if you are not available at these times, then you can contact me by email or after class to make an appointment. And prerequisites either 50/30 or 5800 or the consent of the instructor. So if you're a graduate student and you are confident that you have sufficient background to take the course, then that's totally fine. And previous experience in computer software, such as R, Python, MATLAB, is not required, but certainly it's helpful. And 50/30 slides are on the website, so you can check at times to see how to the code in R. And R is the primary and almost the exclusive language used in this course. And duplication of materials with other courses. So I have run this course as Math 5890 until winter 2020, just before COVID. So if you have taken these courses, basically this course is the same one, so they don't take this course. And any data science master's students here? No. DSA 6000 is similar to this course, so I don't really strongly recommend this course if you have taken DSA 6000. If you want to take both courses, then you can consult with your advisor. Maybe they focus more on analysis and we focus a little more on statistics. So still the flavor is slightly different, but the course materials are similar. And lecture. Okay, so this kind of upper undergraduate, graduate courses, I assume that you are interested in the course material. So I expect all students attend all lectures unless special reasons. So if you are ill, of course, you can skip the class, or you have the job interview. Sometimes you have to skip the class, but otherwise, they attend all lectures. And turn your video on. I think I appreciate that most people have turned on, but certainly, it's helpful to understand. I mean, to focus on the lecture when you turn on the video. So that you are looked by other people. That means that you can concentrate more. Okay, so I got some chat message. I don't think I have. Sorry. Okay, maybe R. Maybe. Sarah, you mean that you haven't used R?
Yes, that was answering your question earlier about.
I see. Sorry. I should have checked it earlier.
That's okay.
Yeah, and MD. Oh yeah, if you don't have a camera, of course you cannot turn on the camera, right? But as long as you have a camera, then turn on. Okay. And if you don't have a camera, maybe you can, ask questions during lecture to actively participate it. Okay. And office hours only in Zoom. So last semester I have office hours in both in Zoom and in my office, but no students appeared physically. So this semester, I decided to office hours in Zoom only. And the textbook, Introduction to Statistical Learning with Applications in R. So this is the very popular book in very popular book in statistical learning or machine learning. But this year that we have a new version. So in this last August, the second edition appears, and it has more contents. So basically, they added several sections. The one is neural network, and the another is the multiple testing, and maybe the other is survival analysis. And since neural network is so important these days, probably that we will cover neural network also in this course. Yeah, and you can download the textbook from the website, the official website, so that you can get it. And some people still prefer printed version, and it's certainly worthwhile, maybe to protect your eyes. But anyway, so it's available online also. And computer environment, we use R and R Studio. So download the R and R Studio into your computer. So if your computer has Windows or Mac OS X or Linux, then these software are free. So you can download and install it. So first you can download R language, and the R Studio is kind of an editor, so integrated development environment, IDE for R language. So my recommendation is to install R. Then if possible, that you can install LaTeX. LaTeX is the document management, a kind of the word processor for scientific documents. Then R Studio, because R Studio, if you want to compile the PDF file, it uses the LaTeX program. So if you install the LaTeX first, then you have less trouble to create PDF file. R Studio itself works as long as you have installed R. And R Studio is necessary only when you compile file to submit the homework. And if you are not successful to install R Studio, I will upload a sample document made by R Studio. So as long as you mimic to that format, then that's fine. So the basic idea is that when I ask you to submit homework, I would like to see your code, outputs, and figures in readable way. So and R Studio optimizes that format, so optimizes to that format. So I would like to have the readable documents. So that's the point. So if you are not successful to install R Studio, you can mimic the format of R Studio. Yeah. Yeah, that's it. And the course outline. Yeah, so you can read the materials that I will discuss this in the first chapter. And learning outcomes. Yeah, so basically, this is very applied class. So of course, understanding concepts and the ideas are important, but also use R language to apply the statistical models, and also do some data analysis in the course. So it's very practical, and after the course, then you should be comfortable to do the basic statistical analysis using the machine learning models. So I developed this course a few years ago because these days we need more methods than just linear regression or logistic regression. So I have work experience in the financial institution, and I did the macroeconomic analysis and some analysis on financial markets. At the time that I only need the linear regression, logistic regression, basic tests. But these days we need more advanced methods even in industry. So that's the motivation that I developed this course. Actually, yeah, I worked in the Bank of Japan, the central bank in Japan, and actually about 4 or 5 years ago, I met a person who came from the Bank of Japan, and they said that now that they use more methods than before. So certainly these materials are the materials covered in this course is useful for the real world data analysis. And quizzes and homework, the 3 to 5 quizzes, they will be assigned every lecture in Canvas and due in 2 to 3 days. Yeah, so it requires the both understanding of concepts and also computer implementation. So some questions are just multiple choice. So as long as you understand the concepts, you can answer with 15 seconds. And some other questions, they require you to calculate something in our language. So you need a little more time. And the homework will be assigned the 2 to 4 times a semester and the 1 week prior to due date. The work independently and submit your work as a PDF file created by our studio. And full credits are given only when your work has a professional level quality. So the idea is that you have to write a document readable for non-statisticians in real world setting. So just explain everything clearly. So that is the point. And especially if your outputs and figures are missing, then you will not get full credits and in some case will not be graded. And midterm exam, 1 take home only. And yeah, so mostly data analysis and coding. Of course, it has also interpretation. And final project, so as similar to 50-30 or maybe 68-40, we have final projects. So you develop a plan by yourself, then you collect data, for example, from CDC, if you are interested in health-related data. Then do data analysis, maybe do data cleaning, data analysis, then make a presentation. So this is synchronous course. So I expect you to make a presentation during the Zoom session. And the presentation date is the last 2 days of the lectures and also the final exam period. And yeah, and this replaces final exam. So if you don't make a final project presentation, then you will not get the course credits. And at first, I will ask you to submit the project plan so that you are on the right track to make a successful presentation. And the grading, quizzes and homework 40% and midterm 24% and final project 36%. It's almost similar to 50-30. And the grade 80% or more in weighted score, you will get an A. I would like all of you get the B- or better. Yeah, and the important dates, the take-home midterm due, possibly it will change a couple of days, but around February 21st. And oh, sorry, I think there's some mistake, like final project plan due March 31st and final presentations these days. And we have about 15 or 16 students, so possibly we need more time on the final exam date. So is any of you taking the course after this time, like from 7 p.m. today, I mean on Tuesday, Thursday? Or do you have any schedule, like you have to work from 7 p.m. on Tuesday, Thursday? So just make sure that you are available from 5:30 to 8 p.m. on the final presentation dates. No, the final presentation of the April 28th. Then we can make more final presentations. We can set up the more final presentations. So each presentations will be maybe 12 minutes to 30 minutes. So 12 minutes, I said. So in 1 hour, probably we can do 4 presentations. So 2.5 hours, probably 10. Yeah. And presentation dates will be determined later because there's often some students drop the course in the middle. So I will set up presentation dates in March. Okay, so these are references on basic materials of R. Yeah. Yeah, so after I accept questions, that I will ask you to introduce yourself. So just think about it. But do you have any questions about course or syllabus?
I had a question.
Sure.
Would you be willing to provide an example of what a professional level quality work should look like? I think that's what I struggled with last semester, was making it look as professional as possible.
Okay, so basically the submission, homework submission will be done by R Markdown. So I will upload the sample solutions to maybe the Stat 5030 homework. Then I expect that your submission is similar to that. Actually, some students submit even better ones. So yeah, I will upload it. Yeah.
Thank you.
Yeah. Okay. And other questions? Okay, so after this, I would like you to introduce yourself, about your name, your major, and why you got interested in data science or statistics. And after that, I will have some breakout sessions so that you can interact with other students. Maybe 3 minutes session and the 2 sessions. Okay, so maybe I will now start to ask to introduce yourself, maybe by alphabetical order of first name, maybe. Antarang.
Yeah. Hi.
Yeah. Thank you.
Hi guys. Name's Antarang Sharma. So I'm a master's student studying statistics. So that's why I'm taking this class, because it's, overlaps very much with what my interests are. I guess I just like statistics. It's, you get answers to questions and stuff. Sometimes answers aren't very apparent, and helps give you tools to, make sense of some things that may,
I see.
things that you might not know. So yeah.
Okay. Yeah,
that's me.
You took the Stat 5030 also, right?
Yeah.
Yeah. And
so,
maybe some others. Maybe you took
I took regression analysis.
I see. Yep.
So yeah,
okay.
This is my second
Great.
class.
Okay, thank you.
Thank you.
Brennan.
Hi, name's Brennan Steinbauer. I'm a graduate student as well, studying mathematical statistics. I think it was my high school biology teacher that got me interested in statistics and all the cool projects we would do, and kind of helping us along how to write papers. So that's how I got interested.
I see. Oh, that's great. Yeah. Okay. And Mariam.
Hi, everybody. My name is Mariam Diop, and I'm actually a math major, and I'm just interested in math in general. Yeah. So yeah, I do.
I see. Yeah. Sorry, I think that just a moment, please. Okay, so next, Myra, sorry, Myra. I don't know. Myra, your mic is off. I'm not sure. She's not here now. Maybe later. Nick.
Hi, my name is Nicholas Farkas, but I go by Nick. I'm a undergraduate senior studying computer science, and I plan to minor in statistics. I also plan to get my master's in computer science, but data science really interests me. And I've talked to a lot of data scientists through internships and stuff, and they said that a really solid knowledge of statistics is extremely important. So yeah, I've just been trying to take as many as possible.
I see. Thank you. Yeah, the Paula.
Hello,
sorry.
everyone. It's okay. My name is Paula Chipaliai. I'm an undergraduate student studying psychology and minoring in statistics and Italian. I plan on going to graduate school for industrial organizational psychology, and a strong statistical background is also very highly recommended, but I always liked research and math, so this feels right.
I see. Yeah. So sometimes, math students don't know, but the psychology uses statistics very heavily. So yeah, certainly, yeah, that makes sense. Priyanka.
Hi everyone, I'm Priyanka Aire, and I'm a graduate student at Mathematics Department, and as well as I have started my master's in statistics. So that's why I'm taking this course.
I see.
Yep.
Okay.
Thank you.
Thank you. And Rajesh.
Hello, everyone. My name is Rajesh. I'm a master's student in mathematical statistics, and I was first interested in statistics in high school. I had AP statistics. There's a lot of real-world applications in it, and so that's what interested me about statistics.
I see. Yeah, I got interested in statistics for the first time when I'm in high school, in the I think the high school senior. The reason isn't really serious. I went to the boys' school, and there was a school festival in October. And the boys' school, so the girls came to the festival. So I asked the first part. I asked the girl to go for a dinner. Okay, so she rejected, and I asked the second girl the same question. Same request, and she rejected, and the third person, she rejected. Okay, so I talked to the first girl, and she accepted to go for dinner with me. And at that time, I thought that okay, so with the first three girls, all of them rejected. The empirical probability is the 0/3, so 0. But that does not mean the true probability is 0. So that's very complicated from the frequentist's view. So after that, I finally reached the idea of Bayesian statistics, and that's the first time I got interested in statistics. So I wasn't very serious about the study, but still I got interested in statistics. Anyway. Robert?
Hi, my name is Rob. I'm a junior majoring in statistics, and I like this course because I kind of just like the mix between programming and math.
I see, yeah. Programming language is the very important part if you want to get a job. That's certainly true, and also it's interesting to analyze data. Sai?
Hi, I'm Sai, and I'm a senior majoring in statistics. I'm taking this class because I aspire to become a data scientist. So I'm taking this
Okay.
class to learn more about.
I see. Yep. And Sarah?
Hi, I'm Sarah. This is my last semester in order to get my bachelor's degree in mathematics. I don't know if I necessarily have an interest in statistics. This course just completed my degree for me. I've only ever taken one statistics course, so I don't have anything against it. I just don't have much experience with statistics, so.
Yeah, that's fine. Yeah. So I hope the mathematics and statistics are a little different. So yeah, so just try to get used to it. Then
Yeah.
that's great. Yep. Yeah, and Shiv.
Hi, can you guys hear me?
Yep.
I'm a senior undergraduate computer science student who is interested in math a lot. And then I minored in mathematics, took intro to machine learning, which interested me in data science. And then I figured I would take this, which also counts as a math credit.
Mm-hmm. Yeah. Yeah, computer scientists are good at mathematics and also computer languages, and it sounds perfect. But I think it's probably the most important thing for computer science students is to understand the data as realization of random variables. So often the engineers and the computer scientists see just data as numbers, but the statistics is a kind of special to see data as realization of random variables. So probably if you focus on that, then probably you will be the perfect in all aspects. Shuraya.
Hi everyone, my name is Shuraya. I'm majoring in statistics and minored in computer science. So I majored in statistics because I like working with data. So hopefully I get something out of this class.
Yeah, also I really like data since my childhood. So that's very good. Victoria.
Yeah, hello everybody. My name is Victoria Wright, and I'm graduate student. My major in mathematics and minor in statistics. I love statistics. That's why I follow statistics.
Okay, yeah, thank you. Yeah, and the Mira again.
Yeah, hi, sorry, I walked out of the room for a second. I'm Mira. I'm in my last semester of my undergrad for graduating in double major in math and biochemistry.
I see. Yeah, okay. Thank you so much. Yeah, so now I will make several the breakout sessions, maybe 4 sessions for 3 minutes. So you can chat anything about, what you have done in the winter break, or what you want to do in the next semester, or what courses are you taking, or whatever you want. Okay, so yep, I will set up 4 breakout rooms randomly. After 3 minutes, I will shuffle it for another 3 minutes. Okay, start. Okay, so students in room 2 does not come back. Anyway. Okay, so I hope you enjoyed the talk. So I will reshuffle it for another 3 minutes. So yeah, again, start. Okay. So I don't know. I could not shuffle the room, or you see different members in 2 sessions. I don't know.
Not entirely different, but that's okay.
Oh, okay. Sorry.
Oh, I had 2 new people.
Oh, new people. Okay, I see. So I think just sometimes it's random, but still we have some duplications. Okay. Okay, so now we start the lecture. So slides. Sorry. Yeah, slides are available on the website, so you can see. Yeah, so after chapter 1, we discuss a little bit about our language also. So chapter 1 is introduction. So at first, what is the probability and statistics? So what is the difference between probability and statistics? Maybe I start with simple question. So when we spin a penny, so what's the probability get the head side up? So, you know, the probability. So of course, if you do only 5 times, maybe that's 3 out of 2 or something like that, but the 3 out of 5 or something, but the what's the probability that you get a head when you flip a penny? Oh, okay. So all people said the 50%, but then, okay, so could you distinguish the head side and tail side of a penny? You can distinguish the head side and the tail side, right? So the one side is the Lincoln and the other side is what? Some building, right? So you can distinguish 2 sides. So why you expect the probabilities are the same? Actually, the answer is about 20%. If you flip a penny, you spin a penny many times. Tail side is slightly heavier. If you spin a penny, it spins 100 times, then most likely heavier side comes the bottom, and the lighter side appears as the top. So that's why that we only have the 20% probability. So why you say the 50%? Because the probabilists assume that. So probability is a kind of to design a casino. So based on mathematical assumptions, you made arguments. So suppose that the penny landed the head side up with 20% probability, the 50% probability. Then if you spin the penny twice, maybe you get the head twice in a row with 25% probability, and so on. That is probability theory. But the statistics is different. The statistics is a kind of to play in a casino. So based on data, we decide. So you play 100 times, you spin a penny 100 times, you count how many of them are heads and how many are tails. So basically, the statistics are more data oriented, even though it looks it's developed based on probability theory. So here is another example. So suppose you rolled a die 100 times, out of which the face of 1 occurs 10 times. So interpret the result. So when you say you roll a die, usually we assume that you roll a fair die that is the 1/6 probability for each side. So probabilist's answer is the chance of getting the face of 1 is 1/6. So let X be the number of ones when you roll a die 100 times, then probability that x is equal to 10 is about 0.021%, or probability of x is 10 or less is 0.043%. So with 4.3% probability that we will get 10 times or less, we go to the face of 1, the 10 times or less. So that is probabilist's way of thinking. So what's the statistician's way of thinking? Okay, so I don't know if the die is fair or not. Maybe, you know, the face of 1, you can see the dot is larger than other size. So that means maybe that face is a little lighter than the other face. So maybe more likely we get 1. Or if we have the same size of dot, maybe it's heavier. So maybe less than 1/6 of probability. So the best estimate for the probability of getting the face of 1 is 10 over 100, because we got 10 times out of 100. So 0.1 is the best estimate. But of course, it has some variability. So in some way that we can calculate so-called the confidence interval. So a 95% confidence interval for the probability is 0.049 to 0.176. So still that we cannot, you know, exclude the possibility that the face of probability of getting face of 1 is exactly 1/6. So we have some range, maybe 5% to 17.6%. So that is our estimate. That is statistical way of thinking. So that is the difference between probability and the statistics. So this word, probability is to design a casino, and the statistics is to play in a casino, is the words by the Professor Korostela at Wayne State a few years ago. And he's really excellent to explain concepts in easy words. Yeah, here is the some reference on what's the probability to get the head size up when you spin a penny. So I think some physicists do research on this, and they concluded that that is actually about 20%. If you flip a coin, the probability is a little different, because the number of flip is usually, you know, less than the spin. So if you spin the penny, then it rotates maybe 100 times, but flip only a few times before it lands. So it's a little different, and actually it's closer to 50%. So now that we have learned that what's the probability and what is statistics, do you have any comments? Okay, so the data science next. So this course title is the Introduction to Data Science. What is data science? The data science is to extract knowledge or insights from data. And this is the Wikipedia's definition. So basically the knowledge or insights. So we focus a little more on the implication, like business implication. So that is the difference between statistics and the data science. And the data science is perceived as a combination of 3 components. One is statistical and mathematical modeling, and the other is computer implementation. And the third is the data analysis, and maybe also business intelligence. So implication to real world problems. So we need some balance between these 3. And we are in mathematics department, so we focus a little more on the modeling, but also that we emphasize the computer implementation and the data analysis. Also, probably you have heard the word machine learning. When you introduce yourself, some of you have mentioned machine learning. What is machine learning? Machine learning is a branch of mathematical statistical modeling of the data, but it emphasizes the automatic detection of pattern, for example, like the letter recognition. So automatically they recognize the handwritten digits or something like that. And also it focuses on the forecasting performance rather than interpretation and correctness of the models. Yeah, so forecasting performance and the correctness of the models are a little different. Right? Sometimes we have some variable which may be useful to predict the outcome, but we are not sure sometimes. So in such a case, if we emphasize the forecasting performance, we include that variable. Right? But that is different in other problems. For example, the drug development. So when drug may be useful for some disease, but we are not sure, then that drug will not be approved by FDA. So we have different focus. So here the machine learning focuses more on the forecasting performance. So we include more variables, more information to do decision and the prediction. And statistical learning. Okay, so our textbook's title is Introduction to Statistical Learning. What is the difference between machine learning and statistical learning? Actually, statistical learning is not really a common word for concept. So besides this textbook's title. So most machine learning models have a statistical foundation. So the statistical learning is a kind of the same thing as machine learning, but maybe the word can be interpreted as machine learning with emphasis on statistical justification. Yeah, for example, you have studied the least square method in regression analysis. And the regression line in simple linear regression minimize the distance, vertical distance between data and the resulting regression line. So if we have 4 data points and this size is say epsilon1, epsilon2, epsilon3, epsilon4, then least square methods minimize the summation of epsilon I square. This, okay. So that is the entirely just computational algorithm, but the statistics gives this some justification. For example, suppose that this error is distributed normal, then minimizing this quantity corresponds to maximum likelihood estimator in statistics. So more justification is given in statistics. Do you have any comments or questions about concepts such as probability, statistics, machine learning, or statistical learning? Maybe some other fields, people in some other fields have different way of thinking. Okay, and prerequisites. So data science requires a variety of knowledge and ideas: mathematics, probability, statistics, machine learning, and computer implementation, and the data analysis, and even more. So often, especially maybe 10 years ago, the mathematicians complain about, okay, so this machine learning book is not clear mathematically, so I cannot really understand. Then, the machine learning engineer's answer is, okay, so you are not smart enough to understand machine learning because you understand only mathematics. But the machine learning has a much wider area to cover. So mathematics and also statistics, maybe statistics is also mathematical, and plus some more modeling, machine learning, and computer implementation, and also data analysis. So 5800 focuses on probability and statistics, so more mathematical concepts, maybe slight computer implementation. 50-30, it covers statistics and also computer implementation and data analysis. And 58-20, that we are more towards the modeling and the machine learning. But still we have the similar mixture of the theory and the computer implementation and the data analysis. Any questions? Yeah. So based on your background, if you have taken 5800, maybe you are stronger in statistical theory, but maybe computer implementation and the data analysis, you have to focus more. And if you have taken 50-30, maybe you can focus more on new modeling ideas. And also computer implementation and data analysis come with the new models. Yeah, that's it. And yeah, so now I go on to the concepts of the statistics and machine learning. So how are data perceived in statistics? So data are not just numbers. So in statistics, data are perceived as a realization of random variables. So originally it's random, but it's already observed, so it's not random. Yeah, so some students in Stat 1020 asked me question, why this random number tables is a table of random numbers? Because, numbers are already printed. So it's just numbers, not random. And that's true, but we see those as a realization of random variables. If you use a computer language, then you can get more flavor of random numbers, right? So if you use R language or Python to generate random numbers, every time the new random numbers appear on screen, so it looks more random. But anyway, so our interpretation is a realization of random variables. So this is a little different from some other fields of study. So how is one's academic ability determined? For example, some kids are good at math, some kids are not good at math. What's the difference? What percentages are determined by genes and what percentages are determined by environment? Many people do research on that, such as, okay, so 75% by genes and 25% by environment. But this is really, different from statisticians' view. So if statisticians make a model, we explain ability as some factor determined by genes and the environment and the pure error. So the error may be ultimately explained by genes and the environment. Maybe we haven't analyzed the genes well, or we haven't accounted for all types of environments. Maybe we checked the, how many years they studied mathematics, or which area, which school districts that do children live in. But some other factors also matter. So usually data do not reflect all the information. So some people think ultimately the ability is explained by these two factors. So that's why often the research conclude that like 75% by genes and 25% by environment. But the statistician's way of thinking is, okay, genes determines, for example, 30%, and the environment determines 10%, and the 60% not explained. So error. So this is really different, especially some scientists, such as the physicists, think that everything should be, determined by the rule of physics. So no randomness there. But the statistics, basically, we don't clarify everything. So based on data, we can tell something, but maybe 60% are unknown. So just an error. Especially this kind of attitude is useful when the problem is too complicated to analyze, such as social science. Yeah. So one related quiz question for today. So I will upload quizzes after the lecture. Do you have any questions so far? Okay, so supervised and unsupervised learning. So have you ever heard of supervised learning or unsupervised learning, or both? No. Yeah, you can ask any questions during lecture, and you can make comments. We have several types of learning: the supervised learning and unsupervised learning, and also semi-supervised learning. So I start with the supervised learning. So supervised learning is a modeling problem when a response variable called label is available for the dataset. So the label is the answer, kind of. So that is the answer is known for the sample data. So example 1, estimating a formula for height of students given the weight of students. So if a student's weight is 30 kilograms, then usually you don't expect that student is maybe more than 5 feet. So certainly the weight is one possible information to predict height. And if we have data such as this, we can make a fitted line, maybe like this. And this is regression analysis. And basically our objective is to estimate height for maybe another new student. Then this student's height is expected at this point. Right? But the original data have the both weight and height. So height is label here. So based on those information that we develop a model and to predict the height for a new students whose height is unknown, but weight is known. So this is supervised learning because height is known for sample data. And next example, establish a criterion to distinguish the 3 species of flowers when characteristics such as color, height, and diameter are known, and the species of 90 flowers are available. So maybe we have more than 2 variables to predict the species. So maybe I use the 3D graph. So this is what the color, maybe usually color itself has maybe 3 dimensions, such as blue, green, red, the RGB scale. And yeah, that can be also done in R, but the height and the diameter of flower. Then we have 3 groups, maybe species 1. This is represented as cross, and the species 2. Maybe we have the circle, and the species 3. This is the triangle. Then, okay, so triangle are distributed around here. And another species of flowers are around here, maybe some outlier like this. And the first species distributed like this, maybe like this. Then you can certainly distinguish. It's really not easy to write, but maybe maybe above here, and like this side, maybe species 2, and this side species 1, and this side species 3. Okay, so we divide this 3D space into 3 parts, and maybe some errors this isn't categorized correctly, this isn't categorized correctly, but we can do this kind of thing. And since we know that each flower is either species 1 or 2 or 3, this has a label. So this is supervised learning. So this is called classification problem. In Stat 5030, that we do only binary classification, yes or no, or 1 or 0, or maybe blue or red. But in general, that we can think about these classification problems. And on the other hand, that we have also the unsupervised learning. So this is relatively new, if you studied the classical statistics. And the one is the dimension reduction, or summarizing variables, and the developing a business cycle indicator when 30 economic time series data, such as monthly unemployment rate and monthly industrial productions, are available. So suppose, so what is business cycle indicator? Okay, so we have time index and the unemployment rate, sometimes very high during financial crisis. If economy is booming, it's low, much higher, and sometimes lower. So this is unemployment rate. And also that we have some other indicator, for example, the industrial production. When unemployment rate is high, usually industrial production is low, right? So like this. So almost the negative correlation between these two, but the industrial production looks like this. How about the consumer price? Consumer price is higher when economy is booming. So usually it's similar to maybe industrial production with some delay, maybe. Okay. So anyway, so these three are really similar. So this has negative correlation, this has positive correlation, but it's similar. So if you combine this information, you can get one business indicator. Maybe, I don't know, but maybe IIP is most important, then maybe 2 times IIP plus maybe 1.1 times CPI, and unemployment rate has negative correlation. So if we subtract maybe 1 times unemployment rate, okay, so suppose this is X, then X is a better indicator for business cycle, maybe more the smoother, like this. Then we can see that, for example, this is economic expansion, this is economic expansion, and the other part, this is a recession, and this is recession or something like that. So we have 3 variables originally, but we summarize this into 1 variable. So a kind of dimension reduction. So in terms of regression analysis, if we have 3 variables, 3 predictors, then that means that we regress the response variable on the 3-dimensional space spanned by x1, x2, x3, 3 predictors. But here we summarize x1, x2, x3 into 1 variable. So 3-dimensional space becomes 1-dimensional space. So this is so-called dimension reduction. So for example, the principal component analysis do this kind of job. So this is unsupervised learning. Okay, we don't have to answer. We don't have to answer, but that we combine these 3 variables to create more useful variable. So we don't have a label. Yeah. Do you have any questions? Yeah, and also second example of unsupervised learning, establish a criterion to distinguish the 3 species of flowers when characteristics, color, height, diameter, etc. of 90 flowers are available, but species of them are unknown. Okay, so suppose that we only have 2 axes, just for simplicity, and height and diameter. and we have 90 observations without information of species. Okay, so it's really hard to distinguish species in this case. But if one cluster around here and another cluster around here and another cluster around here, maybe some outliers, then even without label, that we can distinguish these three. Probably, I'm not sure about this center one, but maybe we distinguish this as like this: group 1, group 2, group 3, even without label. If we have label, possibly, maybe this was in this group, or possibly we have some exception, such as this one is actually the same as these observations. It has the same species as these observations. So it may have some errors, but still, if we have clusters, we can distinguish these three groups. So it doesn't have label. So this data set does not have labels. So this is an unsupervised learning. Okay. So it's similar to categorization, but this classification, not really. So this is usually called clustering, maybe. Yep. And sometimes we have something in between, the semi-supervised learning. So basically, okay, so suppose Y is label and X is the predictors. Then some of the observations have both X values and Y values, but some of them do not have the Y values. For example, think about the translation from English to Chinese. Then we have several books. Maybe the Lehman's book in statistics. So this is a famous book. So sorry, we have English version and also Chinese version. So suppose that we want to translate from English to Chinese. And so this is available, and this is also available. And also maybe Casella and Berger's book. This is also the popular, so it's available in both English and Chinese. But maybe the Jun Shao's book, this is not that popular, so English version is available, Chinese version not. Okay. So in this case, we can use the book to see what's the correspondence between English language and the Chinese language. So just a yes. Okay. For two books, but for Jun Shao's book, we don't have Chinese version. Okay, but still, it may be useful to see some information, right? So maybe the textbooks, it's not really clear, but for example, if we analyze what the sentences mean from the ancient, eras sentence, whose, the grammar and the structure are largely unknown, we count what's the most frequent word or something like that, right? And for that purpose, even that we don't have any information on Y value, it can be useful. So this is called the semi-supervised learning. And actually, for machine translate the translation problem, then most documents don't have the label. Only only a few documents have the label. So this is also good area of research. Yeah, and the data competition often is semi-supervised learning in some sense, because their objective is to predict Y value based on this information. So we have the sample data set here, and we have the test data set, but only X is available here. So it's also a type of semi-supervised learning. Some people don't use this information, but certainly this is a big area of research, and the newer and more difficult area of research. Okay. So those are differences between supervised learning, unsupervised learning, and semi-supervised learning. Do you have any comments, questions? What's time? Oh, sorry, it's already 6:50. So, okay, so yeah, we stop here, and maybe yeah, so we stop here for today. So, and the next time that we just finish up chapter 1 and introduce something about R. Then after that, we go to chapter 2. Okay, so I will upload some quiz questions. So just do it in Canvas, and see you on Thursday.
Thank you.
Thank you. Bye, everyone.
Have a good night.
Bye.
I was 10 minutes late. Are you going to upload this on YouTube or Canvas?
Yes, I will upload the video to Canvas. Yes, but
Right,
YouTube. Sorry, YouTube.
YouTube.
Yeah.
Okay.
Yep.
Night.
Professor,
Thank
when
you.
will
Bye.
when will the quiz be due by?
The Thursday night.
Okay, thank you.